Hello everyone, welcome back. Today we are diving into one of the most powerful yet often overlooked SQL operations, that is full outer join. Ever wondered how to merge data from two tables and capture everything even if there is no match? That's exactly what we will cover. By end of this video, you will know how to handle scenarios where you need results from both the sides, and trust me, this is a game changer for complex queries. I will define full outer join, explain you how to write, and then we'll show you many real-time use cases and examples. So buckle up, hit that like button, subscribe if you have not done, and let's get started with full outer join in SQL Server. Let's define full outer join first. Full outer join is the one which combines the results from both left and right outer joins. So we already are aware of these two types of joins we have discussed in our previous sessions. So basically, if you are talking about left outer join, which gives you all the results from left table and matching records from right table, and likewise the right outer join box works like it gives all the return results from right side, matching records from left table. So basically, if you are talking about full outer join, this basically combines both the results. This returns all the records from both the tables, regardless of whether there is a match between these tables or not. So there are certain cases, scenarios wherein we really need full outer join. So we are going to explore those scenarios. So you can see one example is I have a customer table which contains customer ID, customer name, customer address, phone number, and order ID. So customer might have placed some order here. So you see that Lena Roy, who is having customer ID 4, has not placed any order. That's why the order ID is null for Lena Roy, right? And then we have order tables wherein we contains all the order details. Order ID 100 is for shorts, and the rate per item is 1000 rupees. Indian rupees, 1101 order ID is for pant, and then 800 Indian rupees, and 101 cap, and the rate is 300 Indian rupees, and like this. Okay, so these are two tables, and what I'm going to do is I'm going to perform a full outer join on these two. Okay, and here is the result. The result says that it scatter all the records from left table, irrespective of if the guy has placed any order or not. For example, Lena Roy, belonging and staying at Hyderabad, she has not placed any order. That's why these are all null here. And we can see two orders out here also, shoes and socks, for which no customer has placed the order. So we may need this kind of data, wherein we need data from both the tables, irrespective of they have matching records or not. And there we go for full outer join. Let's explore some real-time scenarios. Before exploring the real-time scenarios, this is the way that we write. Select, this is the list of columns from first table. This is an alias. C, full outer join. FULL outer join orders alias O, and then on customer.order ID equals O.order ID. And this is the result that we have seen. The first use case, merging data from two systems. So we have two systems at a different place, and we are going to integrate these two systems. And so we are going to merge data from these two. So there is a possibility that there are rows existing in both the data sets. There is a possibility that rows in unique to one data set, but still, if there is unique records or matching records, we wanted to merge them together. And that's where we can do full outer join out there. So you see customer records from CRM system and sales data from an e-commerce platform. There are two places, and I want to combine those two, right? There could be some matching records, there could be some non-matching records, and that's where I'm going to put a full outer join on these two. And here is the result. This pulls data from sales data from e-commerce platform, and this pulls customer records from CRM system. Let's go and see the next use case. Data reconciliation. For auditing purpose, a full outer join can help comparing records from two data tables. So auditing is such activity which you do to check whether the things have happened correctly or not. Is there any discrepancy or something like that, right? The example is comparing a company's internal sales record with third-party payment gateway. So there is a company which sells products, right? So once the products are sold, the payment is done through payment gateway. So there are many examples, for example, PayPal and stuff like that. So you are going to do payment through them. So at one day, that when you are going to compare your accounts and see, looking into your accounts, you are going to compare both your sales record with the third party payment gateway records. And here, full joins comes into the picture, right? So this is your sales report, and this is the payments that you have done through payment gateway, and this way you are comparing. So you have seen that full outer join is significant in this scenario as well. Let's go and explore more scenarios. So the third is error detection and data gap. Identify the discrepancies or gaps data by joining two tables and finding the missing entries in either. For example, customers who have accounts but no orders, and there are orders with is no customer actually. So this is the one we have seen. This customer, Lina Roy, is there, but she has not placed any order. And there are some orders for which no customer has placed order. So this data discrepancies can be identified and found using full outer join. Okay, going for the next, we have an HR and payroll system. So we have to list all the employees and their payroll records, including those without salaries or contracts. So we have the employee, and we have employee name, payroll ID, an account, amount, a salary. So you see that Sarah and Mike are two employees who has no payroll record. So Sarah has no payroll record, Mike has no payroll record. And there is one payroll, that is two, which has no concerned employees associated. So there is one scenario which in HR and payroll department, we can actually use full outer join to find the discrepancies. Make sense? Having said that, we have seen many use cases and real-time examples, and we also know a little of how to write full outer join. Let's go and see these all in action. So I'm going to take you in the SQL Server Management Studio. So let's go. So I am in SQL Server Management Studio, and I have written queries and scripts for you to save time. So what I'm going to do is I'm going to create a customer table out here. This has got customer ID of primary key, integer type, customer name varchar 100, customer address varchar 200, phone number, that is cat12, and order ID is integer type. Order ID it contains because each customer, if places order, the related order ID will be placed here. If customer has not placed any order, it will be null. Okay, so let's go and create this table. I'm selecting and hitting this execute button, table gets created, and then I'm going to insert couple of records to this. I'm going to insert 4 records out of this. 4 records have got inserted. And then I'm going to create an orders table. Orders table has got order ID as a primary key. This has got some description and rate per item. What is the rate per item? Let's say it sells shirt. So how much price per shirt it is? Okay. So let's go and create this table. Selecting this table and hitting the execute button. Script has got executed and table has got created. And then I'm going to insert a couple of records to this. I'm going to insert 5 records: shorts, pant, cap, shoes, socks. Okay, so these are the prices, and I'm selecting, and the records have been inserted. So having said that, both the tables have got created and records have been inserted. Let's select these records, and I see these. This is Sumit Thakur, Tilaknagar, New Delhi, has this phone number, and he has placed an order number 100. That means he has placed an order for shorts. Likewise, Dino Jason and Vivek Thakur have respectively placed the orders, but there is one guy, Lina Roy, she has not placed any order. That's why it is null. Let us go and try to write a full outer join to both of the tables. So this is the way: select all fields from customer, the first table, alias C, full outer join, order O, alias O, on C.order ID equals O.order ID. Let's go and select. So you see that this shows all the records here. Sumit Thakur, shorts, $1,000. But Lina Roy, if she has not placed any order, the records for order side for Lina Roy is null, null, null. Likewise, shoes and socks are 2 products for which no order has been placed by any customer. That's why the customer side is null. We can check all the discrepancies or any inconsistent or anything, like we can analyze the data by putting the full outer join on these tables. Let's go and see another example. So we have recently seen the employee and payroll example. I'm going to create an employees table, has got employee and employee name. So let's go and create this. Table has been created. Let's get inserted some of the data. John, Sarah, and Mike, 3 records we have inserted. And likewise, let's go and create a payroll table. Payroll ID is primary key. Employee ID is the one which is associated to this payroll and how much amount or salary the person is getting. Payroll table gets created. And then let's insert data into payroll table. Data records have been inserted. Let's see the data. So you see that 101 John, 102 Sarah, 103 Mike, and in payroll we have 2 records. Let's go and put a full outer join on this. The same way, select all from employee E, alias, full outer join payroll P.employee ID, E.employee ID. So you see that employee ID 101 John has payroll ID 1 and he has got the payroll details. Sarah is the one, she has not got any payroll details. And likewise, Mike is the one, he has not got any payroll details. And we have one payroll details for which there is no employee associated. So sometimes back we have discussed the HR and payroll scenarios that gets justified here. I hope that the concept of full outer join which I have explained to you is pretty much clear. Now you can utilize this in your practical scenarios based on the use cases that you will have in real-time world. If you found this video helpful, don't forget to hit that like button and subscribe for more high-quality technical content. Drop your question in comments and I will be happy to answer them. See you in the next one. Bye-bye.